Hello guys, my name is John Michael Reyes and I'm back for the chapter 4 summary and discussion, and this is called or entitled the network access. And chapter 4 section and objectives 4.1 physical layer protocols, identify the device connectivity options, describe the purpose and function of the physical layer in the network, describe the basic principle of physical layer standards. The 4.2 network media identified the basic characteristic of copper cabling, build a UTP cable used in Ethernet networks, describe fiber optic cabling and its main advantage over other media, and connects devices using wired and wireless media. Data link layer protocols is describe the purpose and function of the data link layer in preparing communication for transmission on specific media. Then media access control or MAC compared the function of logical topologies and physical topologies, describe the basic characteristic of media access control method on one topologies, describe the basic characteristic of media access control method on LAN topologies, describe the characteristic and function of the data link frame. And I've already learned and studied the chapter 4, and I'm just here to summarize so that it would be guaranteed. Then physical layer connection types of connection. Then as you can see, there are internet connection, embedded wireless antenna, and Ethernet switch. It is somewhat some in the ports and other stuff. In laptops and other computers, there are also a type of connections. Then network interface card or NIC. It is somewhat the one who used in connecting with each other. Then as you can see in our house or in your house in our daily lives, there are some extenders or Wi-Fi extenders in order for us to have a massive connectivity for the router and some signals. Then next, purpose of physical layer. The physical layer, it accepts a complete frame from data link layer, encodes it as a series of signals that are transmitted onto the local media. Physical layer media, it describes the media types, simply describes the media type. Then physical layer standards, as you can see here, this is an OSI model. It is somewhat pertaining to how a packet has been sent and received. As you can see, if you are sending a message or a packet, you need first is the application, then it would be a presentation, session, transport, network, data link, and then physical. Then it would go for a bit, then again it would be a physical, then data link. In the data link there would be a header, then data and trailer, then the network, the data and header. Then in transport layer it would be segmented. Then in the application data, it is the process where the end user can view the message. Then after that, physical layer characteristics. Function, physical components, encoding and signaling. Data transfers is bandwidth. Bandwidth is the capacity to a medium to carry a data. Then throughput is measure of the transfer of bit across the media. Then so you can see in here, the types of physical media is SHDSL interface, management ports, gigabit Ethernet interface, USB Type A connectors, and some fast Ethernet switch ports. Then in 4.2 in the network media, it is somewhat about in copper cabling and other cables. Characteristic of copper cabling, it is very inexpensive and easy to install, low resistance to electric current, distance and signal interference. Then copper media, There are two types of copper media, and the UTP cable and the STP cable, and coaxial cable. In the UTP cable, it is somewhat just a jacket, then it would be a twisted pairs in order to not have a interference. Then in shielded twisted pair, it is somewhat expensive than a UTP, because in shielded pairs there are still coating, jacket coating, then another coat for the wires. Then the wires will be paired with others in order to receive interference or interfere. Then the coaxial cable, then copper media safety and fire and electrical hazards. Then UTP cabling. Cancellation, properties of UTP cabling is cancellation of EMI and RFI signals with twisted pairs. EMI and RFI is the one that interfere with the signals in a process of, or in a connection. Then UTP cabling standards are the T5668A and B. The difference between A and B is the colors, the green and the orange color. Then IEEE cut 5, as you can see here, the cut 5, then cut E, cut 6, then cut 6E. Then UTP connectors. Types of UTP cable is the rollover. Rollover is somewhat just for a router to a end device and other stuff. Then crossover device is good for both intermediary devices. Then straight through is for an end device to a switch. Then testing UTP cables. In order to test a UTP cables, you should always check the pins or the cable pin outs if it is too long, or you can ping each other because in order to have the connectivity and other stuff. Then fiber optic cabling. Properties of fiber optic cabling: transmit data over longer distance, flexible but thin strand of glass, transmit with less attenuation, immune to EMI and RFI. The properties or the parts of a fiber optic cabling is the jacket, the strengthening materials, the buffer, cladding, and core. The jacket is the one that protects all the things that inside the. Then the strengthening materials, in order for the buffer not to be distracted, the strengthening materials is there. Then the buffer is the one that protects the cladding and the core, and the cladding is the one that in order for the light not to go out, and the core is the where the light has been transferred. Then fiber media cable design. So kasi that's the fiber cable media design. Type of fiber media is single mode and multi-mode. The single mode is somewhat faster than multi-mode, because single mode can travel faster than the multi-mode, and multi-mode is somewhat just for a few kilometers, but a single mode can go into hundreds or thousands of kilometers. Then fiber optic connectors, testing fiber cables, fiber versus copper. As you can see here, the UTP cabling and the fiber optic cabling. The fiber optic cabling has more advantage than the UTP cabling, because as you can see, the UTP is only for 10 MB to 10 GB, but the fiber optic is 10 MB to 100 GB. Then in meters, 1 to 100 only for UTP, then 1 to 100 kilometer for fiber. Then immune to EMI and RFI, it is not immune for the UTP. Then In fiber, it is immune. Then electrical hazards as well, it is immune to electrical hazard. Then media and connector cost, it should be the highest, the fiber, lowest for the UTP. Then installation skill, in installing a fiber optic, you should have a high skill required in installing a fiber optic, but in UTP it is low. Then safety precaution is somewhat low and high in the fiber optic. Then wireless media, properties of media, wireless media, data communication using radio or microwave frequency, types of wireless media, Wi-Fi, Bluetooth, WiMAX, the wireless LAN, wireless access point, and the wireless NIC adapter. Then 4.3, data link layer protocols. So you can see here, the purpose of the data link layer is, what is the layer? The data link layer responsible for data link sublayers are the LLC and the MAC. The LLC communicates with the network layers, and the MAC defines the media access process, providing access to the media and other stuff. Then media access control. Then as you can see here, there are topologies, control access to a media. We need the rule for how shared and other stuff. Then as you can see here, these are the physical and the logical topologies. The physical topologies is somewhat for physical, and as you can see here, the description is web server. Then it is located on the rack 2, shelf 2, and other stuff. But in logical topology, it is in network mode, and as you can see, there are some IP and some gigabit or LAN Ethernet where you locate them. Then one topology is common physical. One topologies are point to point. This one is the point to point. Then hub and spoke. This one is the hub and spoke. Then mesh. Physical point to point topology and logical point to point topology. Then LAN topology. Physical LAN topologies are somewhat star, then bus, ring, and extended star topologies. Then half and full duplex. In half duplex, you can just go for, if you want to receive, you will just receive one at a time and send one at a time. But in full duplex, you can receive and send at the same time. Then MAC access control methods, contention, CMA, the CMA or contention based access, collision detection, and collision avoidance. Then data link frame. The data link frame is header, data trailer, and LAN in one frames, 80.11 wireless frame, PPP frame, HDLC frame relay, and Ethernet frame layer 2 address. In the frame, there is a header, packet data. In the header, you should have a frame start, the addressing type, and control. And in the data, it's just the data. And in trailer, it will always have an error detection and the frame stop. And then the summary, explain how physical layers and services support communication across the data networks. Then it builds simple network using appropriate media. It explains how the data link layer supports communication across the data networks. Then compare media access control techniques and logical topologies used in the networks. And that's all for the chapter 4. Thank you for listening.